Top 10 Greatest Construction Wonders in the World. The Palm Jumeirah in Dubai barely made it into this list. The pyramids rank only third, and the top spot belongs to a project worth trillions of US dollars, a structure that looks as if it stepped straight out of a sci-fi film. How was a sky bridge built across a canyon at more than 560 meters high? The mystery behind the legendary construction methods of the Egyptian pyramids has finally been uncovered, but is it truth or just rumor? And what about the mysterious research station sitting on the Antarctic ice sheet, capable of operating in temperatures below -60 degrees Celsius? How does it survive? From ancient times to today, humans have continuously pushed the limits of engineering. With stone, steel, and ingenuity, they have carved countless astonishing architectural achievements into the surface of our planet. In today's video, let's join Top 1 Global in exploring the 10 greatest construction marvels on Earth. The number one project simply does not look like something created on this planet. Don't forget to subscribe, like, and share to support the channel. Number 10. The Artificial Island. The island before you, shaped like a giant palm tree, is known as the 8th wonder of the world. This is Dubai's Palm Island, the largest man-made island on the planet. Dubai's millionaires invested 14 billion USD, using 94 million cubic meters of sand and 5.5 million cubic meters of rock to build an empire at the edge of the desert, right on the sea. The island covers 250 square kilometers, equivalent to 1,000 football fields. It contains more than 12,000 private homes, over 10,000 apartments, and countless luxury villas. In addition, there are premium hotels, water parks, golf courses, shopping centers, and a complete network of roads, tunnels, rail lines, bridges, and water systems. This project is considered one of the most challenging and extravagant construction feats in history. And if it weren't for Dubai, home to a vast concentration of ultra-wealthy individuals, such a grand plan would have been impossible anywhere else. From its groundbreaking in 2001, through the struggle to survive the global financial crisis to its revival years later, the story of Palm Island reflects the ups and downs of the world economy. It also represents one of the greatest challenges in human engineering. Don't be fooled by the island's current splendor, a paradise for the super rich. In reality, from its first blueprint to its completion, the project endured extraordinary difficulties. Before 2001, Dubai's millionaires, people with more money than they could spend, were determined to expand their luxurious lifestyle out into the sea. And so, the idea of Palm Island was born. Its iconic palm-shaped design is uniquely tied to local culture and stands out globally in architectural history. According to the original plan, the island would extend 5.5 kilometers into the Arabian Gulf, covering 12 square kilometers, connected to the mainland by a 300-meter bridge. Upon completion, the island would host tens of thousands of villas, luxury hotels, and tourism facilities. It became the world's largest and most expensive artificial island, and a new symbol of Dubai. To make the island blend as naturally as possible with its environment, architects completely removed traditional construction materials. Steel reinforcement and concrete were not used at all. After intense debate, they decided to rely entirely on local sand for land reclamation. Considering wave force, storms, and heavy rainfall, engineers built an outer breakwater 3 meters high and 11.5 kilometers long. In the middle of construction, the events of September 11th severely affected Dubai's tourism projects, halting progress for almost a year before a slow recovery began. To catch up with the schedule, dozens of marine engineering vessels were deployed to carry out sand reclamation. Massive dredging ships scooped sand from the seabed and deposited it at designated zones. Once the sand reached a certain height, layers of rock were added to secure it. Even though this step required tremendous effort, it was only the beginning. To stabilize the foundation, 16 quarries across the UAE operated at full capacity. Workers placed 5.5 million cubic meters of rock on top of the sand, a protective armor layer shielding the structure below. The process was so precise that even the position of each individual rock had to be calculated. They were arranged carefully by weight and size to ensure optimal support and proper spacing. After placement, professional divers inspected everything underwater. If any issue appeared, the work had to be redone, a testament to Dubai's determination. By 2003, 2/3 of the island was complete. By August 2008, the breakwater and the island structure were finished. Next came ground compaction. First, heavy rollers were used. Then, giant steel rods were driven into the ground. Their vibration compressed the surrounding sand until detectors confirmed maximum stability. This process took nearly 9 months and required drilling more than 2 million holes. In May 2004, Palm Island finally began its above-ground construction. From that point on, the world's largest artificial island officially emerged before the public. Although the project later faced financial crises and design conflicts, today, most of Palm Island is fully operational. Its luxury hotels, entertainment facilities, and attractions have become top choices for travelers visiting Dubai. The construction of Palm Island stands as a monumental achievement of human engineering, the pinnacle of artificial island development. Building a massive, thriving island upon the open sea is truly a feat beyond imagination. Number 9. Undersea bridge piers. Do you know how the support pillars of giant sea-crossing bridges are built beneath the ocean? They aren't simply poured straight onto the seabed like many people imagine. Instead, engineers create a dry, empty chamber underwater. The idea sounds impossible, almost absurd, yet this is exactly how the world's most advanced bridge piers are constructed. First, workers steer a ship loaded with massive steel sheet piles to the designated location. Each steel pile is as tall as a 5-ton 6-story building and almost as wide as a car. Using a gigantic hydraulic hammer, engineers drive these piles deep into the seabed. Each sheet pile has special interlocking edges. Once driven in tightly, they connect together to form a watertight wall, separating the construction zone from the surrounding sea. To prevent seawater from seeping through tiny gaps between the piles, engineers use a double-layer barrier system. Inside the outer ring of sheet piles, they build a second inner ring. The half-meter gap between the two rings is then filled with concrete. After the concrete hardens, the double wall becomes completely sealed. Only then can the seawater inside be pumped out, creating a dry working space beneath the ocean. But a new challenge immediately appears. Once the seawater is drained, external water pressure pushes inward, risking a collapse of the entire structure. To solve this, workers first install a strong steel framework inside the enclosure before draining the water. Then they lay a 2-meter thick concrete slab at the bottom. Once hardened, this slab becomes smoother than ceramic tiles and fully prevents seawater from rising again. At this stage, barely half the work is done. Next comes the critical part. Workers assemble a dense network of steel reinforcement inside the chamber. Every step must be precisely calculated. After this, concrete is poured into the mold. When it fully dries and cures, a brand new underwater bridge pier is complete. The sheet pile enclosure is removed, and the bridge can finally be built on top of the pier. In reality, the cofferdam method is only suitable for shallower waters. When the depth exceeds 12 meters, engineers switch to the steel pile foundation method. A giant steel cylinder is driven into the seabed, and the mud inside is dredged out. Then a reinforced steel frame is inserted and filled with concrete, forming a solid foundation. Multiple piles are built this way, and the tops are bound together to create a massive underwater pier. This method is used for projects requiring extreme precision. Whether it's the cofferdam technique or steel pile foundations, both represent the most advanced technologies in modern marine bridge construction, showcasing humanity's highest level of underwater engineering. Number 8. The undersea tunnel. After talking about underwater bridge piers, let's move on to another engineering wonder beneath the ocean, the undersea tunnel. You may have wondered how underwater tunnels are built deep below the sea without seawater flooding inside. How are they constructed so firmly that they can stand unshaken under millions of tons of seawater? At present, more than 20 undersea tunnels exist across the world. Among the most famous are the Channel Tunnel between the UK and France, and the immersed tunnel of the Hong Kong-Zhuhai-Macau Bridge. These projects are milestones in the history of human engineering. Compared to tunnels built on land, Undersea tunnels are far more difficult and demanding. They require extremely advanced technology, expert engineering, and precise execution. Today, there are two primary methods used worldwide to build undersea tunnels: the immersed tube method and the tunnel boring machine method. The immersed tube method involves manufacturing tunnel sections in advance, floating them to the construction site, sinking them onto the seabed, and then connecting them together underwater to form a complete tunnel. The underwater tunnel of the Hong Kong-Zhuhai-Macau Bridge was built using this method. However, it is only suitable for shallow coastal waters. For deeper oceans, engineers must rely on the tunnel boring machine method. This technique uses a massive tunnel boring machine. The front of the TBM carries a huge rotating cutter head that drills forward, digging through soil and rock while pushing the machine ahead. The rear end is equipped with a strong shield that supports the tunnel walls. In the middle, a precision assembly system installs precast concrete segments, forming a solid tunnel lining as the machine advances. From the outside, the entire tunnel boring machine looks like an enormous metal serpent, slowly burrowing through the seabed, carving out a tunnel beneath the ocean. This is currently the most expensive tunnel construction method in the world. A single large TBM costs an extraordinary amount of money, a true world-class megastructure built quite literally with gold-level investment. Number 7. Offshore oil rig. You might think that offshore oil rigs are built up from the seabed, but in reality, they are not. These massive structures are first cast, assembled, and completed on land. Only after that are they transported out to sea, positioned at their designated location, and anchored to the ocean floor. At this stage, because the sea surface is constantly moving, the entire platform sways back and forth. Under such conditions, oil extraction would be impossible. To solve this problem, engineers flood the bottom chambers of the rig with water. This lowers the rig's center of gravity beneath the surface, making the entire platform significantly more stable. The structure of an oil rig is also fascinating. At the edge sits a gigantic crane. Next to it is the living area for workers. Surrounding the platform, you'll find a helicopter landing pad for crew transfers, and beneath it, lifeboats ready for immediate evacuation in case of an emergency. Most important of all is the flare stack. It burns off excess flammable gases from the oil in real time, ensuring safety and preventing catastrophic accidents. After understanding the upper structure, let's look at how the rig actually extracts oil from hundreds of meters below the seabed. When operations begin, the rig's crane guides the drill head into a large casing pipe and lowers it to the seafloor. Once the drill touches the seabed, it starts rotating, drilling straight down into the deepest layers underground. After drilling to a certain depth, the casing pipe stops descending. The drill then continues deeper. Once the required depth is reached, the drill is withdrawn. A smaller casing pipe is inserted and cement is pumped into the pipe. Using high pressure, this cement is forced outwards into the gap between the casing and the surrounding rock. After it hardens, it forms a stable pipe wall. This process is repeated again and again until the oil reservoir is reached. By then, a complete cemented well casing has been formed, and oil extraction can begin. It sounds straightforward, but in practice, it is incredibly complex. The level of precision, danger, and cost involved highlights just how valuable petroleum truly is. No wonder oil is so expensive. Number 6. The train that passes through a building. If you haven't seen it with your own eyes, it's hard to imagine a train not only traveling through underground rock layers, but also passing straight through high-rise buildings, creating a unique symphony between modern transit and the urban skyline. The train that passes through a building at Liziba Station in Chongqing, China, has become one of the city's signature attractions. Not only do locals marvel at it, but even world-class engineers visit to admire this extraordinary achievement in railway construction. Riding this train allows you to see panoramic views of the city while experiencing the tension and excitement of a train gliding directly through a residential tower. This incredible structure, however, was not easy to build. Due to the city's rugged terrain and dense urban traffic, the train line could not always go underground. In some areas, passing through a building became the most efficient and least disruptive solution. In 2000, the local government decided to construct commercial buildings and the monorail station simultaneously. This meant that from the very beginning of the building plans, engineers reserved a dedicated space specifically for the train to travel through the structure. To ensure smooth operation and avoid disturbing residents, the train system and the residential building were built using completely independent structural systems. Additionally, the monorail trains use air-filled rubber tires and pneumatic suspension, significantly reducing vibration and noise during operation. Every detail was carefully designed. If you ever have the chance to ride it, you will witness firsthand the beauty created when engineering ingenuity meets the living heartbeat of a city. Number 5. The High Altitude Bridge. This is the highest aerial bridge in the world, the Beipanjiang Bridge, located on the border between Guizhou and Yunnan in China. The bridge spans the two provinces with a total length of 1,311.4 meters. Its vertical height, from the deck down to the river valley below, reaches an astonishing 565.4 meters, equivalent to a 200-story skyscraper. Standing on the bridge and looking down will make your legs tremble. Anyone afraid of heights might even faint on the spot. Driving across it feels like traveling through the clouds, both terrifying and exhilarating. According to official data, the entire bridge weighs 30,000 tons and uses tens of thousands of steel components, along with 8.55 million high-strength bolts. Even more astonishing, there are no bridge piers in the middle. From a distance, it looks like a gigantic structure suspended entirely in the sky. To keep this massive bridge stable at such a height, engineers used 112 pairs, or 224 individual suspension cables, each stretching tens of thousands of meters, to hang the entire structure in place. Like a colossal dragon soaring through the valley, it creates a legend of engineering in midair. A megastructure of such scale, precision, and beauty absolutely deserves its place in the world's top 5. Number 4. The Dubai Tower. Dubai is not only home to the iconic Palm Island, it also boasts the Dubai Tower, better known as the Burj Khalifa, a structure the entire world will never forget. The skyscraper rises to a staggering 828 meters. The sheer amount of material used is astonishing: 330,000 cubic meters of concrete and 62,000 tons of steel. Yet, the massive volume of materials is not the most remarkable part of the Burj Khalifa. The true engineering miracle lies in how an 800-meter skyscraper can stand steadily in the middle of a desert. Dubai sits on desert sand. Engineers drilled 140 meters below ground and still could not find solid bedrock. This meant that if the foundation were built directly on such loose sand, the entire skyscraper would sway and eventually collapse. So how did they solve this problem? Engineers devised a brilliant solution. They drove hundreds of friction piles, each more than 30 meters deep, into the ground. The deeper these piles went, the greater the frictional resistance they generated. Eventually, the piles and desert sand fused into a single, immovable force. This process alone took nearly 2 years and required immense manpower and resources. Next, workers built the tower's structure on top of this friction pile foundation. They used high-strength steel reinforcement, welded into a dense framework. After adding extensive formwork and pouring concrete, the foundation gradually took shape. Because daytime temperatures in Dubai often exceed 40 degrees Celsius, workers could not build under extreme heat. As a result, most construction took place at night, demanding exceptional discipline, precision, and endurance. A challenge at the very edge of human construction capability. You might not imagine the level of genius behind the design. Dubai is only a few kilometers from the Persian Gulf. Salt water can seep underground and corrode steel reinforcement. To prevent this, engineers applied cathodic protection. The reinforcement steel was made the cathode, and a titanium mesh was added as the anode. When connected to a DC power source, electrons concentrated around the steel, preventing corrosion entirely. Then came the construction of the tower's main body. From above, the Burj Khalifa resembles a blooming desert flower. This design is not only visually stunning, it also maximizes sunlight exposure. ensuring every room receives natural light. Areas that cannot be illuminated directly by the sun serve as the building's central core, where elevators are installed. To further stabilize this core, architects incorporated buttress structures, which reinforce the tower and also serve as walkable corridors. Finally, thanks to these ingenious design concepts, the 828-meter Dubai Tower was completed, becoming yet another brilliant masterpiece in the architectural history of Dubai. Number 3. The Egyptian Pyramids. This is one of the most mysterious places on Earth, honored as one of the 7 wonders of the ancient world, the legendary Egyptian pyramids. Before us stands the Great Pyramid of Khufu, the largest in all of Egypt. It is made from 2.3 million stone blocks, rising to a height of 146 meters, with each block weighing tens of tons. From the outside, this triangular structure looks simple. Yet the question of how so many massive stones were fitted together so perfectly, allowing the pyramid to stand unshaken for thousands of years, remains a challenge that 99% of modern builders could not solve. For the ancient Egyptians, who lived 4,600 years ago during the Bronze Age, such a feat seems almost impossible. In 2013, scientists discovered mysterious drawings left behind by pyramid builders near the Red Sea. These records suggested that ancient peoples once mastered a special technique. They allegedly created the world's largest lens, capable of focusing sunlight to temperatures of 1,000 degrees Celsius, hot enough to melt even the hardest stones. Egypt possessed millions of cubic meters of limestone. According to the theory, workers mixed it with white kaolin clay and poured the mixture into pre-prepared molds. After cooling, a chemical reaction hardened the minerals, forming stone blocks similar to those seen on the pyramid's exterior. The Egyptians then selected one out of 230,000 geometrically perfect triangular layouts and began their ultra-precise construction. What emerged is the structure we see today, a monument that has stood unchanged for millennia. Countless architects have attempted to replicate the pyramid building process, yet they always encounter details that seem impossible to explain. These complexities only deepen the pyramid's enigma, making it an irreplaceable masterpiece in the history of global architecture. We believe that for countless years to come, the Great Pyramid will remain one of the most magnificent and glorious chapters in the story of human construction. Number 2. The Polar Research Station. This may be the most durable house in the world. Even in temperatures below -60 degrees Celsius, it remains intact and can even move freely. How is that possible? This is the Halley 6 Antarctic Research Station, located on the Antarctic ice sheet. It sits on the Brunt ice shelf, deep in Antarctica. Because scientists must stay here year-round for research, the station requires far more time, precision, and engineering expertise to construct. Look closely, and you'll notice the station resting on a series of short, upright legs. These legs are actually hydraulic columns. The reason for this design lies in the environment. The Brunt ice shelf is 150 meters thick. Temperatures can drop below -60 degrees Celsius, and wind speeds can reach 160 kilometers per hour. Under such extreme conditions, normal buildings would never survive. To withstand this environment, architects designed a chain of bright blue modular buildings. The outer shell is made from special materials resistant to freezing temperatures and violent winds. The hydraulic legs beneath the station are mounted on giant skis, meaning the entire structure can be raised, lowered, or even relocated when needed, allowing it to adapt to constant changes in the ice shelf. Since beginning operation, Halley 6 has delivered outstanding scientific results, ensuring smooth and efficient research work. And across Antarctica, many similar stations exist. They stand as extraordinary achievements of architectural intelligence, perfect unions of engineering and human knowledge. Number 1. The Desert City. This is Neom, Saudi Arabia's futuristic megacity project, expected to cost trillions of US dollars. Stretching across desert plains, mountains, and canyons, it extends an incredible 170 kilometers. Unlike traditional cities, Neom is built in a revolutionary linear form. The entire city rises 500 meters high stretches 200 meters wide and cuts inland from the Red Sea in a perfectly straight line. Its striking shape gives it an unmistakably futuristic presence. Even more astonishing, the entire exterior is wrapped in gigantic mirrored walls. From afar, it appears almost invisible, blending into the desert landscape. These mirrors reflect sunlight, helping to stabilize the internal temperature of the entire city. Neom is designed to house up to 9 million residents. The whole city runs completely on renewable energy, from wind to green hydrogen. All household waste can be fully recycled. According to the original plan, the city will have no cars at all. Food delivery and parcels will be handled entirely by drones. Its high-speed rail is designed to reach 500 kilometers per hour, meaning you could receive your meals within minutes and travel anywhere in the city in just 20 minutes. The sense of technology and futurism is vivid. Ground level is a green zone, while the middle layers are residential areas. It feels like something lifted straight from a science fiction novel, a scene once thought possible only on film. At first, many believed such an ambitious design would collapse under its own idealism. But Chinese construction firms have now partnered with Saudi Arabia, and the project has officially begun. Whether Neom will eventually look as futuristic as the concept renders, we will have to wait and see. Which of these 10 extraordinary megastructures impressed you the most? Leave a comment and let me know. And don't forget to subscribe, like and share so you don't miss the latest videos. Thank you everyone. See you next time.